back. Alright, so, what I was doing before my internet tanked and I had to unplug and replug it, what I was doing was I was saying, look, now I can get 2048 tokens just like that, and the only difference is I'm not controlling the code that actually tries to push it onto the stack, but it'll still return to me and tell me what happens. Now I'm just handling that case symmetrically to handling these two cases, basically. Which is that if I'm finished, I want to do still lexing equals 0, right? So it's like if we get a finished result, then we're done. And then otherwise, if we get a token memory situation, then that could either mean that we ran out of actual memory or that we hit the limit. And that really means that I want to extend this one step further, because this helper could do the work of figuring that out for me. Presumably I want to know as the user, and I don't care if my upper level call does an extra check. So token limit, right? So it's like this token on alloc doesn't have a token limit, but it might run out of token memory, whereas this one has a token limit. And so what I want to do here is say, when we get to the end, if the result is the lex token or lex need token memory, then the question then becomes, well, let's do it this way, right? Boom, boom, and then if token stack out is actually equal to token stack out max count, then that's one case. But if they're not equal, if that's less than, then I want to change my result to lex token, what was it, lex need token memory, lex hit token limit. So lex need token memory, lex hit token limit, right? And then what I have here is two separate cases that I can easily tell the difference between. If I have lex need token memory, then I want to do this, right? Which is basically I grow the memory and then I update my stack accordingly. Otherwise, what I want to do is lex hit token limit, and in that case what I want to do is what I used to do down here, check and see if we need to cancel, right? So now that it's laid out this way, first of all, let's see if it builds. Got one little issue in the new Lexer, first of all. There we go. Let's see about this one. Alright, cool. So that works, or at least it builds, and that means I don't want to keep any of this around because I've got the code in the new format. And now that I have it in this format, it's pretty easy for me to see that I actually want to check the token limit if I do before I do mem as well, or check the cancel here as well. In other words, since this could, hit the token limit at 1,000 or 2,000 right before it's, going to hit that limit, it would then come down here, grow the memory, and then do another 2048 before it ever pulled the cancel state again. So I'm just going to throw in right here another pull for the cancel state. Alright, so now 965. What's going on here? Why is this using ints? Okay. So, suppose we gotta do, yeah, I think that the relex can be done So we start the relex, we then do the relex main, and the trick with relex is we set a limit on how far the relex is allowed to go by giving a token stack size. And if that doesn't work, then this right here, what is it doing? Gets more tokens. Relax non-analog start. Move the tokens. They don't understand. So this is performing. Oh, so this is saying. I see. So this up here says, do you think you can do an inline Lex? And the answer is based on whether or not we were in the middle of a background Lex job or not. If we were already doing a background Lex job, or if we didn't have tokens at all, then we don't even consider this. But otherwise, we say maybe we can do an inline Lex. Then we come in here and we say, did we succeed? And apparently this returns true if it fails, which is wrong. I don't do it that way anymore. But it returns true if it fails, in which case we know that we're, not able to do an inline Lex. And then out here we know, okay, we weren't able to do an inline Lex, so we do all this work. Awesome. So that means the only thing I am responsible for here is recreating the behavior relex non-alloc start and relex non-alloc main. And if worse comes to worse, those were based on doing one token at a time, so it should be possible. But I think we can do better than that. I think we can make it work. And hopefully we don't have to change this code at all, but we might. So to do that, let me put the new Lexer here and the old Lexer here, and we'll pull up relex start. Now, the relex start returns a relex state. Do I still have that in my types struct? Or header, I should have. Okay, so what is in here? We have the file, the stack that we're filling, or editing, and then a bunch of information about the relex that we need to store. Okay. And just a real quick check, does that initialize to 0? Okay, we initialize that with non-alloc start. Gotcha. Okay, so non-alloc start, I have to implement you down here. Lexer link CPP relex state, CPP relex non-alloc start. I want it to have the exact same everything, actually. Let me just grab a copy of this, because a lot of this might be exactly the same. And then, let's see, where will it go wrong? I don't know, I think we have get token. Yeah, let's just see. Okay, yeah, so that one is actually not changed at all. That's just initializing some state that it has to read tokens to find and stuff. But the data structure that I'm using hasn't changed at all, right? I'm still using the same data format, so that should still be exactly the same. Because it doesn't do it. It looks like that's a read-only thing. Because all it does is I see it getting tokens in 2 spots. Other than that, what operations does it do? Like none, right? It's just not doing any stack operations, basically. Yeah, it's reading, but it's not writing the stack. Okay, great. So now, let's grab the old Lexer, and let's look at everything that went into doing a relex non-alloc main. I'm just going to move it all over here, and then I'm going to read it on that side. Yeah, that was the paste bug. Okay, hold on. I've been wanting to debug this, and I haven't been able to trigger it, and now it's finally triggering. So let's take a look. Changing tracks for a moment, folks. Instead of doing the lexing, we're going to debug the paste bug in 4coder finally. That's been eluding me for a couple days. There it is. Boop. Paste. Okay. So we come through here, and we get the source string, which is this long chunk of data that is basically all that code that I'm trying to paste. And let's see, we get the next cursor position is the position left plus the source size. That seems fine. So I'm gonna assume that that hasn't become broken magically. So next cursor position is that. Alright. So this is where the cursor is supposed to be. I'm suspecting that what's actually happening is the cursor's not ending up there for some reason. So let's try here. Boom. Where did the cursor end up? Oops. That's not what I want. Okay. So the cursor's in the correct spot right now. Now what I'm going to do is say, let's add a watch on that. And I'm going to take the address of that variable there because I want to see when that changes, because that's correct. Alright, please notify me when that address changes. Go. Alright, where did it happen? FileView.cpp not found. Oh, I've edited FileView.cpp. Alright, so let's just look at the disassembly, I suppose. I can still get call stack information. View move to cursor. View end cursor app step. Okay, so this func file still exists. Alright, so end cursor scroll updates. Right, so it came in here and it decided. Let me read the code in 4coder real quick. So we're looking at file view end cursor scroll updates. It came in here and decided that it needed to move the cursor to the view. That means it did this. It saw the scroll change, but not the cursor. That's interesting, right? So okay, I want to see if I can figure out the repro steps for this now that I've got it triggering, and then what I'll try to do is get it to trigger again where I can see it. So I have these two files. Let me close all the files. Close all code. Oops. What's the name of that? Default bindings. Close all. Include. Close all code. Yeah, that's supposed to work. What about something like open menu? Okay, that worked. Alt X. Close all code. One second. Not sure why that's not working either. I'll have to look at that. I just discovered like 3 bugs. It's only closing one thing at a time. Close all code. Very interesting. Close all code. Close all code. I wonder why that is. Anyway, what's this? Another bug. Alright, so this happened while, what? Trying to kill the file? So we said, step there, and then we went to kill the file, we went to show file, and that's where it tripped up? Whoa, that's weird. View, how did we get a null view? So view is somehow null here. Try kill file. How did you give them a null view? View show file. Do I have line numbers, by the way? 3244. Might be a little different now, but I don't think it'll be too much worse. Yeah, that's even the right function call. Try kill file. So the view it got here was null. Which shouldn't be allowed. So what happened there? You got called by interactive view complete at line 3289. Try kill file. Yeah. And yeah, I passed you a null view. I see. So view show file, that should go right here. And try kill file should not show view file afterwards. Okay. So there's one bug fixed. So let me, while I'm here with a version that can actually rebuild the real 4coder, see if we can get this working. Right, so I need to go back to the target and switch back to the old Lexer so that I can actually build this fix. Which means the new stuff isn't going to work there. And I deleted that. Ooh, darn it. Alright, well I'll just keep deving in this old version. Then, okay. So let's just get this finished, and then we'll go back to chasing down that paste bug if I still have time once this is done. Okay, we just need non-alloc main now. Let me pull some stuff up, since I've lost all the files now. New Lexer, the old Lexer, Lexer types. Alright, so give me my Lexer, and if I scroll all the way down to the bottom here, do I have Relex in here? Relex file limited does not appear to be used anymore these days. I wonder what this did. Relex. Non-alloc main. Relex. Non-alloc start. Okay. So what I was going to do originally was copy this, paste it here, ignore the paste bug where the cursor gets to the wrong spot, because the cursor in the view voice got set. Why would it think just the scroll got set? It's very weird. Yeah, I gotta get that under control. I thought that all that was fixed, but this paste bug proves there's still an issue. And it's still showing up, so Something's amiss. I should really try to tear that up tomorrow. Okay. So let's see, what does this get token do that's so special? I give you some tokens and the size and an index, and then you say, look, if index is less than the stack here, then just get it from there. Okay, I see. So this is just to append my end of file token that I don't actually store in the arrays, even though I want to. So eliminate this once we actually store the EOF token in the token stack. Okay. Now what about Relex non-alloc main? What is it doing that's so special? Grabs the Relex state, takes the token stack, and Relex end, which I'm not sure what that means. Let me take a look. Relex end. Relex non-alloc main. Relex end. Ah, so that's an out. That's an output. Okay. So Relex non-alloc main, we grab the stack out of the state, we grab the tokens out of the stack, we shift token starts. The first thing we do is we shift all the starts after the Relex position, right? So after every token after this point is not to be affected anyway, so we shift all their starts. And then what we do is we say, okay, for the rest of the tokens, we need to relook at what needs to happen there. So that's like, get PP state. Okay, so that's just extracting information out of the state flag of the token, which I'm not sure that our Lexer is properly using yet, but it should be fine. We can start using that. Yeah, this relies on Lex data, which is a little bit concerning. Oh yeah, this is the hard part. This is the tricky one. It looks like. So the issue is Lex data is that thing I've eliminated. And what Lex data did was it was sort of the state. I now just call it Lex data, but it's not set up quite the same way. And let's see. Get the state. Okay, so what I need to know is, let me visit the new Lexer on both panels real quick. What does the new Lexer believe in terms of the Lex data? Right, it needs that. Oh, I have to fill that out, don't I? Yeah. Token start, position, Lex FSM, white space FSM, PP state. So this is the one right here that I would need to fill. Everything else I think I could say is still clear to 0. Key Q classes. so don't need that. Um, Okay, so this just needs to be a Lex data that's cleared to 0, and then I need to set the PP state based on whatever gets returned there. I need to set the position. I'm guessing to 0, maybe? Chunk minus equals s dot position. How does that work? So it sits down to Lex this whole chunk. Oh, does that even work? That just looks totally broken if I have to call this multiple times with different token stacks. Oh, yeah, this isn't ready yet. We've got an issue. So let me switch back to the old one in 4coder, and we've got to do another series of tests. So first let me fix that. So, file view CPP, job callback, still lexing. Yeah, so this is how the new one will work, but I need to revert back to the old one. I don't feel like figuring it out again, so I'm gonna just real quick pull up my repository here and go to the source, and let's see, file view for it, file view. How am I not seeing it? Here it is. And in here I want to find the job full Lex, and I want to do this. So, there we go. Now I've got a version for new Lexer and a version for old Lexer. Okay. Does that work? Awesome. Okay. So now, yeah, we need to switch to the build. No, not build all, just normal build. I want to build experiment again. I have just discovered a new issue. Yeah, so now I need to go fix stuff there. So, pull up the new Lexer 297. When I'm running in the experiment, it wants new Lex as a namespace thing, 979. New Lex. 97. 1023. 1026. Wait. Let's take that all out. Okay. So yeah, I can't implement Relex until I have this other thing working, which is that I need to be able to resume with more memory on the same chunk. So far, all I've ever done is made sure I could resume, but based on the assumption that I end at the chunk that I, um, you know, that I put in, that the whole chunk got used, and it was only the end of the chunk that caused the termination. I haven't actually tested correctness for when I run out of stack memory, so that's what I need to do now. Because it looked to me like that code was wrong when I was reading it. Just plain old wrong. So let's go down to experiment. Yeah, so when we run the experiment right now, I'm just telling you how many, the size of the chunk. I want you to now also have max tokens in there, right? And the way that we'll do this is say go ahead and run the new Lexer, and while you're doing everything else that you're doing here with all that, I'd like to say so there's the state, here is the chunk, here is the output stack, and here is the max tokens, right? Or more like, let's do it this way. If max tokens is 0, then do all the old logic that we were doing. That way we can keep that working that way. And then here, we'll have a brand new one that says, alright, if the max tokens is not 0, then we're going to do something like this. Chunks and stack. There we go. Except now, we're going to do keep doing that while we're still lexing, and we're going to put down max tokens there, right? And then we'll just have here still lexing will be 1 to begin with. We'll get the result here, and then if result equals lex finished, still lexing equals 0. Right, so that way we can test for smaller chunk size, like stack sizes, right? And what are you talking about? New Lexer, lex finished. It's right here. Oh. I see. So now, when it goes to run the experiment, I want to tell it, here it's running chunks. It does that, and then what we're going to add is say, look, so if you're running with chunks, then don't do stack for now, and if you're running with stack, don't do chunks, and we'll combine them as our final test of this thing later. But if we want to do token limit, then run the experiment, on the chunk experiment data. No. This got to be like limit experiment data. You with this verbose level, 0 there, and token limit here, right? If chunks begin T, end T, verbose level C. C equals chunk start, C is less than chunk end. Chunks. Not sure I totally understand this logic here. What are we comparing? Where we're just running it for each time for there being a chunk, I guess? So let's just put the token limit in here, I think. Because this is already not using chunks, so we might as well put it there. And then by default, we'll just say, let's set the token limit to be extraordinarily high. Right, so it's like something really big like that. And now if I run the experiment, let me bring this back into view here. If I run the experiment, I shouldn't get anything failing, right? That's weird. So I passed all the chunked ones and then it failed right there. Okay, so what's going on? Let's take a look at that. I want to see what happens right here. So max tokens is this gigantic number here. It comes in... Whoa! You're just calling the wrong one, or what's the deal? I don't understand. Stack out 4096. I'm kind of confused right now, actually. So non-alloc, the one you're calling doesn't have the int at the end, and there's another one available down here that does have the int at the end. With the max tokens and everything. You're telling me we're never going there for some reason. Okay. Yeah, you're not going to this one. What? Oh my goodness, what is this? Oh shit. You just moved the whole window? Why would I ask for you to move the whole, like all of these things with all the tabs and, oh my goodness, you stupid idiot. Alright. How do I grab all of these at once? I don't know where it got the idea of moving all of these tabs into the spot where my files go. Oh, is this what caused it? Yeah, that's it. Great. Okay, so put you down there. And now, let's see. Somewhere around here there should be a call, right? Call. And there's the address right there. So I'm just curious if I can go to this address somehow. Could do it manually, I guess. F631790. F63, so I want to go to 31790. 1790363, so it's these ones, these four. 1790 is what I'm looking for. Huh? What? 631790. 631790. I have no idea what that's about. Okay. Well, let's see here. 570. Okay. So that's getting moved there. Do you want to tell me what these contain? One second. It's raining. Gotta close the window. Let's see. XMM. Where do you live? SSC. There we go. XMM0 to XMM2. What's file CPP? Interesting. Okay. So we're moving XMM0 into this pointer here. That doesn't make any sense. Alright, just gonna ignore that. Don't really know. So then move that to the XMM1 register, move that to the XMM0 register. Definitely a debug build, doing all kinds of weird things. EDX. Don't understand why that one's not shown. Let's just turn on all these things and then I can look around. CPU segments, floating point, MMX. So I guess it's not in any of these, actually, as it turns out. But that's fine. We can live without it. I'll just hover over it to find out what value it has. It's very weird. Okay. So you're doing all this work. When do we get into there, I wonder? So 125 is still talking about file data size, right? No. What is 125? Not sure. Well, I'm just going to get over it. So there's the big number there, right? So that did get put in a register. And then we're going to call this function here. But yeah, we went to the wrong one. It's linking to the wrong function somehow. Okay, well. So you linked to the wrong function now. What? What are you doing? I'm totally confused. What on earth? I don't know where EDX is in this little view here. R15D, what about that one? Yeah, so we definitely did that, and we put it in something called EDX, which is not visible here for some reason I can't comprehend, but now it's calling this version directly. What the hell? Okay, let's say I set this to just the number 1. Okay, so that has nothing to do with it. Okay. So it might be that the PDB is corrupt somehow. Let me try some stuff. Delete star PDB, delete star exe. There we go, that's different. What are you complaining about? 274. Token limit. Max tokens. Okay, so that's a different address, which is good. What? You're going to the wrong place. I can't understand. When I call this function here, I'm passing it a max tokens. I wonder if I just did this real quick. Now I should go, I can't compile, because that part seems to be working just fine. Then I go, there you go. Okay, so now this is just really weird. So what? How are you still getting? How did it put them in the same way as before? Whoa. This doesn't make any sense at all. Is it inlining my function right here? Is that the issue? Oh. Okay. Let me change something. No. Experiment. Bring me the experiment build. Don't optimize anything. Let's try that again. There we go. That makes more sense. Okay. Okay, so now with that over, we can keep on stepping. And well, first of all, I'd like to fix all these stupid things I did. So new Lexer, same name please. Should have known that's what it was. I should have known. go. Now it's coming in here. And what I'm doing here shouldn't affect anything at all. So it didn't Lex everything, but it did. What? Okay, so it came up with 125 tokens. What about this one over here? Alright, when I run experiment, what about the other one? What about the correct one? Where is that one? Data file size. Correct stack. Yeah, so here's I'm setting the correct stack up. And the correct stack has a count of 125. Okay, what just went wrong there? LDTB, free LDTB. What? Oh, man. Yeah, that all looks fine. It stopped right. It stopped filling in new stuff right there, so it didn't overflow. It didn't. Oh man. All right, let's take a look. Very confused by this still. So it comes in here. The temp stack here has a max of 496 and zeros there. The tokens are the same tokens that this stack has, right? Yes. Now, didn't we clear this to 0 up here? So that's a bit odd, right? Okay, so that's just backwards. My bad. Wonder how long that hasn't been doing anything. There we go. Then we pop in here. And we start working on stuff. Eventually we should get a notification that we ran out of need token memory. We got to the end of the chunk. What does 1 mean? That doesn't mean finished. Need chunk. Why would it believe that it needs a chunk? Okay, I want to see. Did I lose the stream again? No, I don't believe I did. Okay. I want to look at my yields and say all of the yield ones, anywhere where I say I need a chunk. Something's going wrong somewhere. because this guy shouldn't think he needs a chunk. So I don't think he should think that. Maybe I have to pass it a 0 so that it doesn't think that. Oh, well I don't care about that. Let's turn off the chunks. So no more chunks. Okay. I see. So the only way to make this thing not think it needs a chunk is to give it a 0. But you can always just say, oh, it says it needs a chunk, but I didn't, you know, null terminate my string, so that's that. That's fine. I'll just wrap that up with a helper. So he says, oh, I need a chunk. He goes, let's see, temp stack count 125. Everything's good. And then it's going to try again. I see the issue. So yeah, let's wrap up that in another helper there. So right now what we've got is just these ones here that require null termination, but what I could do is say and when I say lex size, I mean lex and end it based on like a certain file size, right? And so then I'll take out max tokens in this version. We will take a lex non-alloc sputter chunk size temp stack, and then out the other end, if sputter position equals full size, pass in a 0 like so. And pass in that 0, and then set result equal to that. That's if result equals lex need chunk. Then we're going to test and see if we're actually at the end, and if we are, then we'll just go ahead and supply the null termination ourselves, so the user doesn't have to. Set up the result again, and then we'll return the result. Now the only thing that happens here that is a little wonky is what does that mean? What about other cases, right? If I need a chunk here and then I pass in a 0 there and then it tries to push something on the stack and goes, the stack's not big enough, or something like that, it seems like this here actually needs to be let's just do it correctly while we're looking at it. This needs to use the duff routine stuff. So basically that means we need to do how is that going to work? We're going to have to do it manually, I think. So the reason that won't work is we would need a second Lex data PC for the outer values, and that's just not going to work. So okay, what we do is we say, look, if this needs a chunk, or if this is anything other than need a chunk, if it says it needs more, if it says it's finished, or if it says it needs more tokens, then just go ahead and return that. But if we need a chunk, check and see, are we actually at the end? And if so, try to null terminate. But if the problem that could happen is this might not, even though we null terminate, it might go, oh, I need memory, or I need token memory. So then what we want to be able to do is say, look, if this, if that comes back as need token memory, what do we do? And the answer is something like, when we first run this whole thing, what we want to do is say, check and see if the putter position is already equal to full size, then just do this, right? So if we're already at the end, just do this. If we're not at the end, then try and see what we get. If it says we need a chunk, then do what we would have done if we were right at the end, right? Because now we're right at the end. Now do this stuff and try to finish. So if this here says something like, oh, I need token memory, the user will get it. It say, oh, here's more token memory, but the S position will still be the same. It'll still be full size, right? So then technically, let's make that greater than or equal to full size, because I'm not sure what'll happen there. And there we go. So that seems good. And then what I can do is do a Lex size non-alloc. I can do a version of this, which will basically be just like this, right? And the point is to add a max tokens, and then to do this stuff, right? Only this time, instead of doing a Lex non-alloc, I'll do a Lex size non-alloc, right? And I'll have the full size right here, right? So now I've got the ability to limit on both the, or to limit on the max tokens, do chunks, and then say, like, I don't want to null terminate this, just null terminate it for me, and it'll do that, which is kind of cool. And that means that over here in experiments, where I'm getting an issue because it's returning 1, we can just switch to this one, right? And that means we'll do this. So if we get to the end, it will hopefully not report to me that it needs another chunk anymore. Now, it doesn't quite like the code I wrote. The compiler doesn't. So what's the deal there? sputter, and yeah, so this should not be temp stack, that should just be the token stack out. $980. That should be token stack out as well. Alright, I'm going to be right back. Alright, let's see, what was I doing? So I just got these new versions working, and I want to see if that fixes the issue where it comes in here and gets a result. Okay, so yeah, so that's going to return a 1. By the way, all of you can kick the can now. And so now we got a 1, but he's going to go, I see a 1, and aha, we're there. So then it's going to try one more time, and it got a 0. Right? And the token stack out. There we go. It completed correctly. Result. Count is 125. Don't need any memory, and there we go. We're out. Alright, so now still laxing equals 0. Alright. So now I want to see if I run it now, does it work better? Haha. It does work. Although now the timing's all off because this one doesn't have to do the multiple tokens thing, and this one does. But other than that, I'm not sure why the numbers are so small, by the way. That's a bit weird too. But anyway, presumably, well, that doesn't make sense. Why would it be? Yeah, that doesn't make any sense, actually. Let's try that again. Unchunked time is now super slow. Oh, I know what's happening. Okay, so let's just well, actually, no, I don't understand. Max tokens. Token limit. It's really big. Should come in here and say, alright, max tokens is huge. So we don't do anything to that, and then we run it. Yeah, I don't understand. So this is running basically the exact same way as it ever has. And yeah, it's measuring totally differently, right? Because that hasn't changed at all. Let me just try one quick thing. Set the token limit to 0 so that it runs through the old code path literally. Yeah, that's more like what it used to behave like, right? So this doesn't make a lot of sense. These are unchunked times. Why is it running so slow now? I mean, that might be because it's not O2. It used to be that unchunked times were like at a 2.0. Hold on, I want to figure out what has changed that it's now running so much differently in speed. Well, while I'm here, I might as well make one other adjustment. So you are going there. You're going there. And you're going there. So you can snap out as much of the extra time as possible, but that shouldn't make any difference. Not at this scale. So then, what is different? If I add O2 back in, that usually made things worse, not better. Yeah. Now it's just running so slow. What's going on there? It doesn't make any sense. Even through this old code path, it's slower. I didn't change anything substantially important from when I started, yet it's crazy slow. That doesn't make any sense. That's like crazy slow. Is the chunk thing messing something up? Chunk. Alright, if chunks, then the first thing we do is with chunks of this size, we run the experiment. But chunks are set to 0, right? Yes, chunks should be set to 0. Are we doing single item? No. So none of that even exists. What happens is we grab all the files. If we have chunks, we don't, so ignore that. We begin time experiment T. We do all this. No, we don't have chunks. So we only ever call this once per file. And then we, one sec. Okay, and then what do we do? We grab the hand-coded time there, and then we do, we're going through this path here, which is the one we've always gone through, and that's weird. I'm pretty confused by this. What's the value of start? We've optimized it out. Okay. That can't be right. Wait, what? Time.fsm, time.handcoded. Whoa! What just happened there? File data. How big is this file? Okay, so somehow... That's what it normally comes out as. That's what it's supposed to look like. Okay. So that is like not doing anything the same at all. It's showing 220 here, and oh, I know what this is. Okay, interesting. So what we've learned is that the hand-coded Lexer was much faster at parsing binary files as if they were C++ code for whatever reason. There we go. That's what it's supposed to look like. I was in the build folder, so it was parsing executable files. Okay. So that weirdness is over. Now, I want to see, although that does bring up an interesting point. To do Alan, how can we make the new one faster? Or in what corner cases, such as invalid files, does the new Lexer suffer? Question marks. Fucon, I don't really want. I mean, I want infinite speed up is what I want. What I expect is about 1.4 because that's what it's always been. Um, and yeah, the Lexer should ignore binary files, but my point is I was accidentally running them on binary files, not intentionally running them on binary files. Um, because I'm not actually, using the 4coder, like it's the 4coder Lexer, but it's not running through 4coder right now. It's just grabbing whatever file I feed to it. And, it doesn't, like, have any way of knowing that I'm feeding it binary versus, code. But, all that aside, uh, it is running faster, as I expect, by about 1.4. The more important thing is that it can run in chunks, which the other one couldn't do. But my point is I'm not shooting towards any particular amount of speed up. The important thing was being able to run in chunks, and the speed up was just like there to make sure I didn't fall below 1.0 as I added chunks, which I didn't. And the fact that I got a 1.4 speed up was just, bonus. Um, Although I do have some ideas on how to speed it up beyond that, if I ever want to. It's not really what I'm doing at the moment. At least not today. So, the point is, now I want to run back to token limits. Okay. Yeah, so that doesn't work at all yet. And, okay, just want to make sure I don't end up in the build folder accidentally again. So what happened there is another problem on the free base. I'm guessing that's probably for a similar reason where we just end up lexing more than we're supposed to. So I'm going to stop it right there, and we're going to go ahead and say, alright, what result do we get? It's optimized, so I can't see. Okay, next time through. Wait, what? Oh, it's the file data free that got messed up. That's odd. That suggests that something went wrong and we accidentally wrote into the file data, or I'm not sure what that means. Yeah, it just shows an F, which suggests that it wrote into the file data, which it's not supposed to do. Yeah, none of that is valid. Okay, I wonder if this is because I've got optimizations on, though. I mean, not the bug. Obviously, the bug can't exist either way. But I wonder if the reason the debugger is not helpful is because of this. Let's try that again. Alright, so 1 time through, 2 times through, we get the result. The result is 2. Okay, so it does go through again. And that doesn't make sense because I'm not actually limiting tokens in any meaningful way yet. So it says here, and it goes, alright, where's position, where's full size, 570 is the full size. Alright, first time through, it works. Second time through, we get a full size, it's big this time, max tokens. We go, alright, let's parse this, let's lex this thing. And it goes, alright, are we bigger than that? No, so we do a normal step. It goes, aha, I need token memory. At which point, I'm like, what? How do you need token memory? How can you possibly need token memory? That would mean that tokens stack out. Oh, I see. I'm still limiting it to 4096. So yeah, I want to allow it to run out of token memory actually. The experiment. Right, so up here, I'm saying if we're finished, or we'll say also, or if we get Lex need token memory. What we don't want is that we hit the token limit, but we have that helper telling us whether or not we hit the token limit or the memory. So now it should come in here and go, aha, I need token memory, and then it'll come out, right? So the reason we were messing stuff up was again because we were lexing more than one time out of the file data, which you're not supposed to do. And then it was writing to the file data for some inexplicable reason that I haven't figured out totally yet. Let's see if I can run that through to completion. Yes, I can. Okay, awesome. It maybe just like automatically messes things up when you read from the wrong spot. I see if you kind of asking me a question about the Lexer. The Lexer doesn't do any of that parsing stuff. So eventually it will understand user-defined stuff, but what I'm making now is just a thing for lexing out tokens, and it has the exact same behavior. It's literally, I'm running the old one and the new one and comparing the outputs to make sure it's exactly the same. I'm just adding new features to the existing Lexer, basically. Hello, subready. So, that was good. I want to see if it was correct. Experiment. Yeah, so that says that everything's coming out correctly, which is good. So now, let's try and set the max tokens lower, which I know will break it. I know for sure. Let's say it only can output 16 tokens at a time. There we go. Now everything's broken. So I want to use my usual approach. Let's start with one of these. Let's start with parser test 1, because that's the one I've already got set up. Let's do, run experiment. You need the token limit, as do you. Or actually the rule was supposed to be you don't get the token limit right now because we don't combine those correctly. Alright, perfect. So now let's just let's just break at the first error and start troubleshooting. So yeah, testing is not putting out all the tokens it's supposed to, for one thing. Type mismatch at 16. So let me put all of these under breakpoints now, and boom. So there's a comment, there's a define. Let me go read that. Oh wait, I want to check one other thing. That token 16, so that's the first time after this loop ended. So I want to just walk through this loop and say, alright, so first time through, what actually happened was we should have got a result of 3, and now we come through here again. We're going to do set the max. Now the max is 32, so that it only will do 16 at a time. And we go in here to parse, and it's going to go, alright, are we done? No, so we're going to do a normal type of parse. And the thing is that we're getting the same chunk that we got last time. So 2 calls, both the same chunk size, and so on. But it still does this step here, where the s dot position gets subtracted out of the chunk. And so that suggests that what I really need is I need to tell the system where the chunk actually starts. Because I don't have any way of this system figuring out it would have to store where that chunk starts, and the only way it could know where this chunk starts is by keeping track of whenever a chunk start happens. It feels like it'll just be much faster if the user specifies where the chunk starts when they give you a chunk. So they say, look, this is the beginning of this chunk, the first character of this chunk is this position, and it's their responsibility to keep that correct to get the right results. Because the alternative is that I have to do some extra work in the Lex data to keep track of whenever I transition to a new chunk. Whenever I say, oh, I need a new chunk, right? Whenever I do a yield that asks for a new chunk, I would then have to advance my chunk start position to the end of the current chunk, right? And then use that start position here. You know, I think I can do that. I feel like that won't cost a substantial amount of speed, and it does make the user's life ever so slightly easier in some cases, probably. So just less ways they can mess things up. I feel like I should do that. So sputter is a Lex data. Alright, so now I need int chunk pose, right? And what we'll do is we'll say right here, we're actually talking about chunk pose, right? And then whenever I doctor yield, if I say I need a chunk, then what that actually means is that the chunk pose needs to get plus equaled by the size first. So doctor yield, where else do we have that? Need chunk, need chunk, need chunk, need token memory. Yeah, okay, so that's it. Alright, so there's that. Well, ooh, we passed that one. That might have been all we needed to do to make it work? Question mark? For realsies? Let's do all of the files. Okay, so that works. We have the ability to do stacks now, right? We have the ability to do growing stacks. Okay, so let's go ahead and do one more level of testing, which is currently we're not mixing chunks and token limit, but now I want to change that up and say let's do a version where we have both, right? And so then I'll test some small chunks with a low token limit, and then we'll know for sure that this API handles all these things. And the way I want to do that is say, look, this right here is the rule if there's not chunks, but if there are chunks, we have a different story. If we're doing chunks, it's going to be something kind of like this, except that except that this part here actually has to get replaced with, okay, so this first of all is if Lex finished, or if Lex need token memory, we get out of there. And then Same thing for the outer do loop. So it'll be, or the inner do loop will be something like this. If we have a still lexing variable, we'll do while still lexing, and then let's see, those two there we want to replace with that, right? So we're using smaller chunks now, but we still have the same full file data size. That's not changed. And we're using that to figure out, to tell the difference between actually needing a new chunk and finishing. And then this here does filling up the testing stack. This here does telling it the maximum number of tokens to fill into the stack per loop. And then eventually it'll get done and come out. Yeah, okay. Ruh-roh. So now what'll happen is if we need a new chunk, we'll get told right here that we need a new chunk, and then it'll loop around and give us a new chunk, and then we can continue. And then this inner loop forces that if we, that we don't do too many tokens at a time to test the idea of having a limited number of tokens. Alright, so what I actually want to do is just run it and make sure nothing crashes. Oh no! What happened? So we're doing c equals 4. Just a weirdly specific time for it to crash. It's trying to free the TB, which it just did the same 4 characters over and over again, huh? That's odd. Okay. Well, you can see it was clearly going /* new line space, /* new line space, /* new line space, which means it was looping on the same characters and never got to the end of that it kept thinking it was parsing one big comment. We should be able to see this. Is there anything else I need to know? This is the first repeat. What is I? I is 1. So I really want to break right here condition when I equals 1 and c equals 4. Alright. Badoop. In we go. First it solves the problem using the old Lexer that we are calling reliable. Then we go and say, alright, we're going to do chunks of size 4. And then it goes, okay. Well, here's the deal. I started parsing right about here. There we go. And let's see, the first character I saw was a slash, and the second character I saw... Wait, hold on. So that slash got me out of the white space skipper. Then the first character I saw was a slash, and I put that into the TB. Alright. The second character I saw was a star. And I put that into the TB. The third one was a new line, and I put that into the TB. And the fourth was a space, and I put that into the TB. Then I had to end because I was at the end of the chunk. And I said, you know what? Can't emit the token yet. So since we're not emitting a token, yeah, so we increased the chunk position by 4. And then we doctor yield and say we need a chunk. Thing is, when we said we need a chunk, this thing checked and we weren't at the end yet, so it was fine. Then this thing said, oh, update your count. Do you need token memory? No, so that didn't do anything. Then we said, alright, what's going on here? Is it in any of these cases? No. So are we still lexing? Yes. Oh, I see, I see. So I need to add a thing that says don't keep doing the inner loop if we need a new chunk. Right, if the lex needs a chunk, we gotta stop doing the inner loop so that the outer loop can provide the next chunk. Clearly. Alright. Looks like we're passing a lot of stuff. Now what I want to do is, since running through chunks has the effect of multiplying the number of tests we do by 16, I'll reduce the repeats down to 1. And then we should be able to run the experiment and bada boom, we get some results. Now the speed up can be ignored safely because we're compiling under debug, and also I'm in the data folder, so not sure how valid that is. Yeah. I think I want to be in this folder. There we go. That's more like it. And still it's saying the chunk time is faster, which is weird. Weird. But, the good news is it passed all the tests. So, there we go. I feel like I'm out of time for today, but yeah, got the Lexer working with chunked input and limited sections of tokens. So now you can say, look, I only want to feed you 4 characters at a time, and I only want you to produce 16 tokens in a batch, right? And once you're done, like, you know, with your 16th token, you're gonna have to stop, and so on. Although now that I think about it, since I'm using such low chunks, what I should do is try a really low token limit too, and raise that up a little bit, just to double check one other thing. Yeah, there we go. So that's good. Anyways, yes, I'm signing off. Thank you everybody for joining, and I'll see you guys around.